11.5 Partial Fraction Decomposition, Part 1. So we're going to look at some rational functions for a while, and we're going to try to break these down. So breaking it down can be done in more than one way. It depends on what type of rational function you have, and then even within the rational functions themselves, some different things can happen. So let's look at an improper first. So an improper rational function would be when the degree in the top is larger than the degree in the bottom. Because keep in mind that an improper fraction would be, for example, 4/3. So in this case, that's a cube, that's an x to the first, so that's an improper. Well, in this case, long division would work, synthetic division would actually work here as well. Long division always works. So let's do that in this case. So we have an x cubed, 2x squared, negative 7x plus 5. And we are dividing by x plus 5. So that means that you need an x squared over here, because x squared times x is x cubed, plus 5x squared. So we multiply this way and then 5x squared. Subtract 0, 2 minus 5 is a negative 3x squared minus 7x. So it means the next thing I need is a negative 3x, because a negative 3x times x is a negative 3x squared. And a negative 3 times 5 is a negative 15x. So when I subtract, just keep in mind you're subtracting here, a negative minus a negative is a plus, so that's 0, and a negative 7 minus 15 is actually plus 15, so that is 8x. Then you drop the 5, so then you need one more 8, so 8 times x is 8x, and 8 times 5 is 40, so we actually have a remainder of a negative 35. So that means that f of x could be written in this way. It could be written as x squared minus 3x plus 8 minus 35 over x plus 2. X plus 5. Okay. So that's something we're familiar with. What we're a little less familiar with would be if it's a proper rational function. So now the degree is less, in the top is less than the bottom. So let's first figure out how we get from one to the other. So if I gave you this and I asked you to combine them, then hopefully you would say, well, that's 5 over x plus 3. And then I'm going to multiply this one by x minus 2 and x minus 2. And on the 7 over x minus 2, you would use x plus 3 over x plus 3. And when you do that, you get 5 times x minus 2 plus 7 times x plus 3 in the top of your fraction. And the bottom of your fraction ends up being x plus 3 times x minus 2. Now that can be cleaned up a little. So 5x plus 7x is 12x. And the negative 10 plus 21 is plus 11. And we can leave this or multiply it out. So in this case, we'll multiply it out for once. So x squared minus 2x plus 3x is plus x minus 6. And so here is a proper rational function, because the degree here is 2, and on the top it's 1. And what we're trying to work on today is how do I go from here back to that? So how do I break down a proper rational function into the parts that it came from? Well, let's go look at an example. So the first case we're looking at is if the rational function's denominator can be broken down into non-repeating linear factors. So keep in mind that x squared minus 5x plus 6 could be written as x minus 3 times x minus 2. Okay? So x minus 3 is a linear factor. So is x minus 2, and it's non-repeating. I don't have an x minus 3 twice, for example. So, well, if that's the case, then I know that x divided by x squared minus 5x plus 6, that came from something that looks like this. So I'm not sure if the top is a 5 or a 7, so we're just going to introduce some variables. We're going to say it's an a over an x minus 3 plus a b over x minus 2. And now we're going to solve that for a and b. Well, I don't like fractions, so I'm going to multiply this whole thing by x minus 3, x minus 2. So this is the same thing as that, so that completely cancels. So on the left, we're left with an x. Okay, the x minus 3 cancels the x minus 3. So then I'll have an x minus 2 left as a factor, and then for the b, the x minus 2 cancels here, so I get an x minus 3 for that. And I'm going to distribute. Then I'm going to collect everything that has an x on the left side, leaving the right side sort of alone. So it's an ax plus bx, so ax plus bx minus 2a minus 3b. And then I'm going to do one more thing. I'm going to factor that x out over here, and I'm going to write this as an x plus 0, and I'll show you in a moment why. And then it leaves me with a plus b here, and this one a negative 2a minus 3b. Okay, now it doesn't look like I have made much progress, but I do know that if I get an x plus 0 over here on the left, and a plus b times x is that, then, well, then we know something over here. We know that's a 1x. Then I know that 1 is equal to the sum of a plus b. I also know that a and b are just normal numbers, so that when I add them I should get a number. And the number I'm getting is 0, so I know that 0 is actually what you get when you do a negative 2a minus 3b. Well, that's a system of equations that we should be able to solve. So I'm going to multiply this by, one multiplied by 3. So we get 3 is equal to 3a plus 3b. And over here I have 0 is equal to a negative 2a minus 3b. So now when I add, I get 3 plus 0 is 3. 3a minus 2a is a. That cancels, so a is equal to 3. And if a is equal to 3, and I know that 1 is a plus b, then b must be equal to a negative 2. And now I can write the original f of x, which was x over x squared minus 5x plus 6. I can write it into its parts. I know it's, let's see, what did we say? A over x minus 3, and a was 3, so it's 3 over x minus 3 plus b, which is a negative 2 over x minus 2. And that's how you break it down. Okay, let's do that one more time. So we have 4 over x plus 2, x plus 1. Okay, same thing, so 4 divided by x plus 2 over x plus 1 is equal to a divided by x plus 2 plus b divided by x plus 1. Again, you multiply by the common denominator, so we're going to multiply everything by x plus 2, x plus 1. That cancels completely over on the left. On the right, you get a times the x plus 2 cancels, so that leaves you with an x plus 1. And then b times the x plus 1 cancels, so you get an x plus 2. So distribute ax plus a plus bx plus 2b. So 4 is equal to x, and you get a plus b again. And in this case, we get plus a plus 2b. So in this case, we know that we don't have any x's, so that means I could write that as 0x plus 4. So that means that a plus b has to equal 0, and a plus 2b has to equal that 4. Well, that already sort of set up, so subtract a minus a is 0, 1 minus 2 is a negative 1b, 0 minus 4 is a negative 4, so b must be 4. And if a plus 4 is 0, then a is a negative 4. So that function, f of x, breaks down into a negative 4 divided by x plus 2. So the a goes with the x plus 2, plus 4 divided by x plus 1. Okay. So that's the easy part today. So now we end up with this one over here. So case 2, the rational functions denominator that can be broken down into repeating linear factors. Okay, so x squared is not linear, but x squared could be written as, and ignore the fact that x cubed minus 8 is factorable. So just look past that, it's actually not helping me. X squared could be written as x times x, and x minus 1 cubed is x minus 1 times x minus 1 times x minus 1. Okay, so the linear factor x is repeated twice, and the linear factor x minus 1 is repeated 3 times. Alright, well, and I'm going to erase that. Just want you to see that that was linear. So what that means is the following. If you have an x squared, and I want to erase a little bit more actually. If you have an x squared in the bottom of a fraction, then that could come from an a over an x or a b over an x squared. If you have x minus 1 cubed, then that could come from a c over an x minus 1, a d over an x minus 1 squared, or an e divided by an x minus 1 cubed. Now please, I'm not saying that they all have to be there, but what I'm trying to tell you is that if x squared is in the bottom of the fraction, and if you initially had a 1 over x and this was like 3 over x squared, then the common part between x and x squared in the denominator would be an x squared. So do you have to have an a over x? No, not necessarily, but you have to account for it. So you have to account for each of the factors as many times as it occurs. So if it's an x squared, then you have to use an x1 and an x2. And you see the same thing over here. Well, now I'm going to do the same thing. I'm going to multiply by x squared. So we're going to multiply this giant mess by x squared and x minus 1 cubed. On the left side, that's easy. That gives you an x cubed minus an 8. What happens on the right side? Well, you get an a. This x cancels one of those, but that leaves you with an x and an x minus 1 cubed. Then you get a b. The x squared cancels the x squared, but that still leaves an x minus 1 cubed. And then we get a c, and then we get an x squared, because we have nothing canceling there, but we do have an x minus 1 canceling there, so we only get 2 of them. And then we have a d with an x squared, but 2 of these will cancel 2 of those, so that only leaves me with 1 of those. And then finally have an e with an x squared, and then the x minus 1 cubes cancels here. So this is the mess that we have. So what do you do with that? Well, then you sort of have to look at sort of some patterns that you see here. So let's say, what happens if x is equal to 0? Now why would I pick 0? Well, I'm picking 0 because if I make x 0, then this one disappears. So the a times 0 times this is 0. So I do have something left with the b here. The c times x squared, so that's 0. D times x squared, that's 0. And e times x squared, well, that's 0s again. So what happens here is that you have a lot of stuff disappearing. So let's fill it in. X is 0. So 0 cubed minus 8, that's a negative 8. Is equal to a is gone, b is still there, and 0 minus 1 cubed is just a negative 1 cubed. And then plus c, that's 0, that's 0, that's 0. So you just get this. So a negative 8 is a negative 1 cubed times b. So negative 8 is a negative b. So we know that b must be 8. So what other number would be great to use? Well, x minus 1, well, let's make x equal to 1. Now let's see what happens. Do we have a bunch of stuff again that cancels? Well, 1 cubed minus 8, so 1 cubed minus 8 is a negative 7. So on the left, I'm doing this right away. So here, if I plug in a 1, 1 minus 1 is 0, so a is gone. 1 minus 1 is 0, b is gone. 1 minus 1 is 0, c is gone. 1 minus 1 is 0, d is gone. 1 squared is 1, so you get e. So you basically are getting b and e for free. Well, that's wonderful. How do you get the rest? Well, I'm going to get the rest by just saying what happens if. So let's make now what happens if x is equal to 2. So I'm picking 2 here because I'm hoping we get some cancellations, like 2 cubed is 8 and 8 minus 8 is 0. So you're going to go a bit more space there. So you're going to get 0. If I plug in 2 here, I get 2, and 2 minus 1 is 1, so 1 cubed is just 1, so I get 2a, plus 2 minus 1 is 1, so I get 1b, right? Plus 2 minus 1 is 1, but that's a 2 squared, so 4 times 1 is 4, so I get plus 4c, plus 2 is 4, and 2 minus 1 is 1, so that's plus 4d, plus 4e. Now keep in mind that we know that b is 8, so I'm going to replace that with an 8. I don't know what c is, I don't know what d is, but I know that e is equal to negative 7. So 4 times a negative 7 is a negative 28. So negative 28 plus 8 is a negative 20. Bring that to the other side. So I get 20 is equal to 2a plus, I took care of those, right? 4c plus 4d. So 10 is equal to a plus 2c plus 2d. Okay. Well, it looks like if I keep plugging in for b and for e that there are 3 variables, a, c, and d, that I don't know, right? So that means I need to come up with 3 equations. So this is going to end up with a system with 3 variables. And those variables are going to be a, c, and d. So let's pick what happens if x equals 3. So 3, that's 27 minus 8 is equal to, so a, so we get 3 here, right? And 3 minus 1 is 2, and 2 cubed is 8. Plus b, and b is 8. We'll plug it in 3, and 3 minus 1 is 2, and 2 cubed is 8. Plus c, and we're plugging in 3, so 3 squared is 9. And 3 minus 1 is 2, and 2 squared is 4. Plus d, I don't know what d is, and then we're plugging in 3, and 3 squared is 9. And 3 minus 1 is 2, and then finally we get e, and e is a negative 7, and 3 squared is 9. So now I need to clean that up. So 27 minus 8 is 19, right? And 3 times 8 is 24a plus 64 plus, let's see, 36c plus 18d minus 63. So 64 minus 63 is actually 1, right? 64 minus 63 leaves you the 1. And the 1 needs to go over here, so that's 18 is equal to 24a plus 36c plus 18d. All those have a 6 in common, so let's divide the 6 out. So that is 3 is equal to 4a plus 6c, and 18 divided by 6 is 3d. So there's my second equation. So I'm going to write those, I guess I'm going to leave it over there, because I'm not sure if I have enough room. So now I need to do this one more time. So now let's see what happens if x is equal to a negative 1. Well, if we use a negative 1, I get a negative 1 cubed, that's a negative 1. So I get a negative 9 is equal to a negative 1, and a negative 1 minus 1 is a negative 2. So I need to do a negative 2 cubed. Plus b, and b is equal to 8. And then I do a negative 1 minus 1, so that's a negative 2 cubed. Plus c, and we need to plug in a negative 1, so that's 1. And a negative 1 minus 1 is a negative 2 squared, plus d, negative 1 squared is still 1, and a negative 1 minus 1 is a negative 2. And then e is a negative 7, right? Yep. And then a negative 1 squared is just a negative 7. So that ends up being a negative 9 equals 8, so that's a negative 8a. Sorry, negative times a negative is actually positive, so it's a positive 8a. Negative, so that's minus 64. Four C minus 2D minus 7. Negative 64 minus 7 is actually a negative 71, so we need to add 71. So we're going to do plus 71 over here. So that actually gives you 62. So 62 is equal to 8a, and took care of that, plus 4c minus 2d. That's divisible by 2, so 31 is equal to 4a plus 2c minus d. So here's the system that you now need to solve. You need to solve, and we'll start with this one. 3 is equal to 4a plus 6c plus 3d. And then I need 10 is equal to a plus 2c plus 2d. And then the last one that I have is 31 is equal to 4a plus 2c minus d. And that's quite a lot of work to solve that. If you do this, you should get a is 24. You should get c is a negative 24. And you should get d is equal to 17. So that means, finally, that I can write this monster with a over x. So the function can be broken down this way. It's a over x, right? And I said a was 24, so it's 24 over x plus b, and b is 8, so plus 8 over x squared plus c, and c is a negative 24, so that becomes minus 24, and that would be over an x minus 1, plus d, and d was 17, so 17 over x minus 1 as a factor squared, and then finally plus e, and e was a negative 7, so minus 7 over x minus 1 cubed. And now that function is broken down. Alright. Here's the summary with two cases then. Non-repeated linear factors. If they're non-repeated, then however many factors you have that are all linear, then you use an A1 and an A2. So we said, the first one we just called A, and then we called it B, and then if you had more you'd call it C, D, etc., etc., etc. Okay, so they use an A to the end so you can keep counting. And then you got to figure out what all those A's and B's and C's are. If you have repeated linear factors, then each of the factors needs to be repeated however many times you have, starting with the smallest one. So if you have an x minus a, for example, let's say that this was to the fourth, then you need an a over x minus a, and the second a over an x minus a squared. We would have needed a third a over an x minus a cubed, and a fourth a over for an x minus a to the fourth. And then you have to determine that. And the determining part, as you can see, is quite a tedious exercise, because I did the first part so that you could set up the system. I didn't even solve the system for you, because that would take quite a lot longer yet. So some of these problems are going to take a good amount of time. Thank you.